Hello, hello. I did not prepare this as much as I normally do. Okay. I don't think I did anything since the last stream. Nope. Very successful last time, which is cool. We have typed snippets now. Where do we use that? It's in the asserts, which is cool. And then tried to do... Okay, we can actually update these now. Mem protect none, must be exclusive. Got... Let's go ahead and print this out with it, because why not? We can now. Has other flags. Yeah, tried to do concat last time. Here. Didn't really work. It's more complicated than I thought it would be. But I may have a better solution for it now. I am falling down in my camera. I don't know what's happening. So we might give this another go tonight, because I really want this and need it for certain things, and it shouldn't be so hard to do. I think what I need to do is, last time I was trying to jam I was trying to jam the identifier concatenation stuff into, well, trying to jam it into the string parsing stuff because I'd store them as strings on the various nodes. But I look for token identifier here. Wherever we get, whenever we see an identifier, we just grab the token text, and that's what we use. So here's an expression leaf. If it's an identifier, we kind of just skip past it and do different things with it. If we are doing a variable declaration, like here, we look for identifier, and we just grab its text and stick it into the variable name. So at this point we have lost the fact that this was an identifier on the tree. Same as here. We just get the text and store it in the nodes, losing the fact that this was an identifier. Yeah, so really what should be happening in these cases is this thing, any of these things with a name, yeah, pretty much anything with a name should not be just copied in there. I guess it can be if it's just a simple string, but if it's a concat node, or if we're doing concatenation, it needs to be if we're doing concatenation, it needs to be a special node on the tree that says, hey, we're concatenating stuff. And it should have children of the things you're concatenating. And really, we should probably do, if we're going to do that, we should do away with the short string name entirely. Or I guess the other route is keep it the way it is, store it as a name, but store, say this was your identifier was like right, store this whole thing as the string, and then in a post pass, once we know what everything is, so theoretically we would have known what var is at this point. In a post pass, do the thing I just said. Either cut this up into multiple nodes or something. Or let that stay until codegen and let it figure it out. That feels messy though. Yeah, I don't know. It's not going to be an easy problem, and well, I think the problem itself is pretty easy. It's more thinking about how do I want to represent that here in the tree, and how much am I going to have to mess with, because theoretically anything that I'm storing right now is just a string that we parse and leave. So like, or we store the string and leave, like even the type here could theoretically be concatenated, right? Anything that is just stored as a string. So maybe we start there. We can just try it. Let's create a new node type for, like, it'll be an expression string concat, I guess. Concatenated identifiers. Would help to spell this correctly. Sturng. So if we do that, and this goes below struct call. Actually, every now and then I want to just recopy this whole thing, because I never know if I'm messing something up over time, and I could verify it, but it's a little easier just to do this. So let's just copy the whole thing and then do one of these. Some more of that. Then we can do one of these. And just go through. Okay. So now we haven't done anything yet, so we still have an assertion in here to test this thing, which we don't need anymore. Can we make better error message for this? What was this? X was not declared in this scope. Oh. Oop, like that. Okay, I don't really know what this is about. There's like no... I'm not sure what this is saying here, so... I will just leave that for now. Don't know what this is saying. I can look at my last stream and just see if I talk about why I wrote that there. Okay, so now let's just take these one at a time, I guess. Let's create a new struct here that's like IDENTIFIER concat, and oh, bump of the mic. We'll say this is a well, we'll say this is a identifier text, or we'll say, yeah, text, and that might be no, it could be a declaref as well. And in fact, let's put this up here because that's why it's there. Declaref. So, could be 0, go with text in that case instead. So, this could be one of two things. It could be just a straight identifier. So like it would be this part, right? The my underscore. Or it could be a declaref, which means we parse one of these, and it would just be this. I think I would just store this. We can lose the concat at this point because it's built into what this thing is. You know what I'm saying? So this is actually down here. Expression info. It's actually one of these. Let's be proper about it. Parser expression info concat. Identifier concat. So that's great. Although that's not really what this thing is. That's why I wrote up there in the first place. Because we definitely want that. We want that on the tree. But I think what this needs to be is... Or maybe we don't. Maybe we actually don't need that on the tree. Let's go with not mucking up the tree at first. So let's just replace this with one of those. Name. Okay. And then we will say... let's go ahead and do that for everything that has a name. So this is where it gets a little scary, just because this is going to require a lot of updates to the parser. A decal ref. I don't think... Well, no, it could also. It could also. Keywords, I guess you could construct them from concatenating things, but I don't think that's a route we have to go down. Types we won't worry about for now. Pre-proc parameters, no. None of that. None of that. Nope. Nope. Pre-proc info. Expression. I don't remember what that is. A pre-proc expression. Pre-proc expression. Oh, that's if a pre-proc shows up in an expression. Are we in parse expression right now? Oh yeah, okay. That's if we show up. Okay. Okay, so that's all the places where that we have a name that we're replacing with this identifier concat. And let's actually put a thing here that says what this is. To support concat directives, this will be used for the name of nodes. So example, my concat var variable on the tree, this will be a new node type whose children with 3 children. My children, my var, this is going to be nothing. I guess pointer decal ref node var and variable. Something like that is what I'm thinking here. Whether that's a good idea, I guess we'll find out. We can always just roll back, but or rather, no. On the tree, yeah, actually, I feel like this might have to be... Because this can't store... Alright, we'll do this. Concat data and Well, really, this is really just a union between those two things. Although it's not really, because we're using the fact that it could be 0. So we'll say this. Concat. So this is actually going to be an array of these things. Of these. Num components and components. So whenever we go to do an identifier, we will stick them in here. So this thing's name, quote unquote, this will say this, the node's name will actually be an array with these contents. 0. This is really what I just described below. This is how it would actually look. It would be 3 of these. The first one, because there's no pointer, its name is my. This one has a pointer to var, which is what this would be up here, and then variable. And then the post pass, when it connects decal refs, it will just have to know to look through these if they exist, which should be easy. So we can connect these up. And then codegen, when it goes to spit out identifier names and stuff, instead of just printing the name, it can traverse this array. That's the plan. Gonna have all sorts of problems now. Because all of these now don't have a proper name. So let's just kind of get started here. Dot name. Hello. Thanks for interrupting the stream. So when we print these out, I need a helper function. Let's get a helper function that says get node identifier name, I guess. It's a little confusing what this means, but so gonna have to switch on everything that has this thing, which are these. So let's do this. Let's take this whole thing, and we're gonna drastically cut out pretty much all of it. Get node identifier name. Okay. We're gonna say result and nothing to do here, nothing to do here, or here, or here. So these all are taken care of here. Let's do this in a way that's less error prone. Okay, so we will cut out all of these. Same thing here. Bit field, yep. Functions do as well. Constructors and destructors I don't think do. Decal. Like they technically have a name, but it's just the name of their parent struct, so I don't think we have to do them. Not this. Actually, maybe this. Maybe this. Decal struct for sure. Union for sure. I guess as long as it has a name. We'll just say to do for the whole thing. Type defs do. Statements don't at all. Assignments don't. These don't. Function calls don't. Did we say decal refs do? They do. Keywords don't. This doesn't. This doesn't. This doesn't. This doesn't. None of the literals do. Operators don't. Includes don't. Okay, I think we're good. Okay, so we are going to say if it's a decal variable, then so really we need construct node identifier. Builds and returns the node's name from its concat table, I guess. So here's the node, and we're going to say no, this is going to take we're going to say construct identifier, builds and returns the constructed identifier from a concat table. Because this is actually going to take one of these things. Identifier concat. Concat data. Or ident data. Okay. So, what this is going to do is we are given one of these. So we're going to say result and for ident data num components. So we're going to loop over all the components. We're going to say component is ident data components index. Okay. If component decal ref So if it has declref, then we do one thing. Otherwise, we just append on this thing's name. This is just text. And for a declref, we can do the same thing. We say result plus equals construct identifier of the declref. Yeah? So here, all we do is say, we don't have to even do it this way. We can just say, assert false, I guess. This is not an identifier. Okay, so constructing identifiers should be easy now. We can just return this. Return node decl variable dot name, right? We just return that. Here we do the same thing, but it's this. Here we do the same thing. Here we do the same thing. So really just we're indirecting out of the different info structs depending on what we're... Okay, we'll have to come back to that. And actually, no, this is wrong. This is construct identifier of this. Right, right. We're doing the function we just wrote. We should probably be calling it. Okay, struct template. Do the same thing. Union, if we have a name, but should be this. So then if name.length, go ahead and do that. Well, actually, I guess it's okay if it just returns an empty string, right? That shouldn't even be a problem. Let it return an empty string. What do we care? Type def is a little bit harder because... No, it's not, because... This is a case where I think we'd be asking for the alias, not the base type. To do, we should just be doing the alias here, right? Don't actually know if that's the assumption to make, but we're gonna make it. Construct identifier out of the alias. Declref. Same thing. Okay. So, now, down here. anywhere where we get the name, info.name, we need to do name is get node identifier name of node. So then all of these can just be name. I guess we're just printing. It doesn't matter that much. We shouldn't be copying this, but you know what? If we're gonna do it, we should do it. Well, I guess that already does that. It's fine. Whatever. No big deal. Okay. Name. Okay, cool. That's all we do there. This can be get node identifier name of node. So can this. So can this. This is all the easy part. This is just our print function. So return type is fine. Because that's implicit conversion. Right. That's still just the return type. That's fine. We haven't updated that yet. This, same thing. This, we can go ahead. This is where we're returning the empty string. So if we have a length, go ahead and put it in there. We can just do this. Right. Type def. This can be. Yeah, so this is going to be. Base type needs handle too. No? Let's do that up here as well. Get node identifier name. Okay. Decal ref. And then keyword, nope. Let's see what all we need else here. That's it. Okay. Let's see if we have any errors in there first. This is 412. Construct identifier of this thing's name. Decal name. Oh, right. I have to actually go through. So if it has a decal ref, this is info expert decal ref dot decal name. What? Oh, I did just call it name. This is decal name. Just to be clear that this is separate from just a... Okay, we're good. So, let's just start going through these. Kind of just exploring here. This could be a disaster, so... 1202. Create a decal ref node. The name needs to be Right. The problem with this, though, when we create a declref node, we want that node's this actually is trickier than just like, do declrefs like, if I did this whole declref, its name needs to be constructed. It needs to be concatenated, which means here I would have to call the function we just made. No, I would have to parse one of these. Yes, I would have to parse one of those. Okay, I think I'm going about this the wrong way. I was sitting here thinking that I need to support this everywhere, but I don't. These are for snippets. And snippets can be way more constrained in what they do. So right now, when we parse snippet, do we do that? No, we parse it as regular code. Here. Yeah. When we do a snippet, we parse it like a regular function. So we just set the root to the snippet node and let it parse like normal. So we do know when we're in a snippet, which means we would only ever have to introduce these weird new nodes in snippets, in the trees for snippets. And then the code that expands those into real code can do the replacing. The question is, how do we get it into the tree? That's the question. So I'm now wondering if this is a bad idea, because we're mucking up the whole tree for this, which I don't think we're gonna have to do. Let's go back on this. That makes me feel a lot better. I do not want to do that. It technically means we're not going to be supporting concatenation everywhere, but now that I'm thinking about it, I don't know if that actually makes sense to do that. So let's start with that assumption, and let's go back on this too. Honestly, I could probably just revert the changes in Git, but it's fine. Give me a chance to think this through. So instead of introducing a new node on the tree, I wonder if I can inject this into... Yeah, this is tricky. I don't know. I don't know. We're back to compiling. So let me do this really quick. Let's make a snippet here. This fails. Doesn't know how to do that. But if I instead just do this, this it also doesn't know how to do. So let's say, let's just print this out and see what happens. So this should be fine. We're not calling this stringify 52. Okay. If this was concatenated, if we confine this to just be snippets that do this, I feel like we can actually get away with keeping this whole thing as the string. And then snippets can handle parsing that on their own. I wonder if that's the cleaner way to do this. Because it feels messy on the snippets end, but that might be fine because they're already doing this weird thing. They're the things that are dealing with like textual parsing and stuff in terms of like replacing nodes on the tree. Let's start there, actually. That seems like a better place to start. So I feel like then the easiest way to implement this is to let the lexer count this as a single token, if I'm doing it that way. This whole thing would be a single token. Which doesn't feel good, but I guess alternatively, I can say where do we do the identifier things? Potential tags. We do it there, I think. Yeah, so there we just get the token text. Here we are creating decal refs. Man. Here we're just grabbing the text. You know what, I guess we can support these one place at a time and just see if this is going to work. So here, this is a variable decal. So let's just go there. Parse variable decal. And let's just see what happens, right? Identifier here. Here's where we grab the name. I really don't want to push this complexity onto, or I don't want to squash the complexity and just have the lexer eat that all as one token. I really don't like that. So we can replace this with expect token identifier. I guess what we can do is let the lexer, one thing the lexer can do actually is just consider is identifier character could be, here's what we can do. Is identifier character will not include the concatenation, but starts identifier will. I think this works. So starts identifier. So this will show up as an identifier. So great. Okay. So now when we parse an identifier here, unrecognized symbol after identifier, unrecognized symbol after identifier. Right. So right here. Right, so here's where we parse the identifier. We're expecting something that we know here. If we see another identifier, we know that this thing is a concatenated thing. Concatenation. Make sure it, this should be in a concatenation. Make sure it is. Should be a concatenation. So we now assert that, or not assert, we're going to say if get token text next. We're going to say short string here. Do we have a starts with? We don't. So we're going to say void start, or starts with string query short string, or this is the query, this is the source. Is substring? No. So we're gonna say query end index is the minimum between query.length and source length -1, and all we're gonna do is return substring ss of source 0 query and index is equal to the query. Let's just test that that worked first. Stop this for now. What do you mean we can't compare short strings? Is that because it's down here? Oh no, it's because it's down there. C++. We'll just put it at the bottom. Who cares? Okay, so let's just really quickly say, if, let's assert that starts with hello, hi. This should fail. This should actually be a string here because we're supposed to be doing this on variables. This is a pointer to test. Okay. Assertion failed. Test does not start with. Actually, no, that's fine. But does it start with hello? Does it start with hell? It does. Does it start with capital H? It does. Does it start with H-E? Yes, H-E-H. No. Okay, great. So, we can say down here, if not starts with get token text. This is gonna be text is get token text. Next. If text does not start with concat, we can do a parse error and say that unrecognized text after identifier text unrecognized text in identifier. The only thing we expect here is concat. Okay. So that means if we don't have that, just make sure that we error, right? If we just had like f concat, that did not work. What did we get? It should tell us what we got. Unrecognized symbol. Why am I not printing that out? Okay. So we actually see what we want, right? But this should really be this. Although, no, it really shouldn't, because this goes until here. We grab the identifier. This starts an identifier, so starts identifier. Peak until non-identifier character. Yeah, we start. Yeah, that should work. So why is it not? Is it because this is not a token identifier? That could be why. Let's just see. Let's go into VS Code. What are we in? We're in the parser 2156. Where's the parser? 21. Hey, look, we're right there. Okay. Just do one here. Next is a pre-proc. Of course it is. It's a pre-proc. Because it sees the pound sign. And you know what? Maybe we use a different symbol for this. Maybe we use a different symbol. Because this complicates a lot of things when it doesn't have to. Like, maybe we do a bash style thing. Like print arguments this way. Or concat them that way. Now, there's no syntax highlighting here. There should be. I would have to go update that in my editor, but I wonder if that's better. Because we already, in the Lexer, I believe we already... Yeah, we already use this when parsing, or a concat directive. So, although, yeah, so that should actually just grab the whole identifier then, I think. So now, it's still a pre-proc. Why? Because I didn't save. It helps to save. There. So now we're hitting the thing we want to hit. It's because it was parsing that as an identifier, or a pre-proc directive before. No period goes in your parse error. So it wasn't even... Yeah, it didn't know what to do with that. Now it knows that this is... Question is, do we want to use a $sign for this? Do we want to use a caret? We want to use a... I don't know, man. An @ sign. At is kind of cool, kind of makes sense. You're saying insert this at this location. Do we want you to do this? Like, probably not. This choice really doesn't matter, but kind of don't have a lot of other options. I think @ might be okay. I might be okay with @. So does this still work if I say, hey, this is an @ sign that starts an identifier too? No. That doesn't work. Oh. Well, first of all, let's extend this and not replace the one that was already there. And you can see we're actually picking up the @ symbol now. So something is definitely not... do we do a $sign thing here? Is prefixed any known type? That's why. Okay. This isn't for types though. This is for names. Okay, if it's an at, right, what are we seeing here? We are seeing an unknown token. That's actually good. That tells us something. That means the token is unknown. Use a Unicode emoji instead of at, yes. When are we gonna get to code just looking like a text chat? So why are we doing that is the question. Here is why. If we see an at, we do the same thing. There we go. Okay, we're grabbing the whole thing now. So now we can say we're no longer going to do this. We're going to say if it starts with an at. Cool. All right, making progress. If it starts, if it doesn't start with an at sign, right, so if we've already parsed an identifier and we see another one, it has to start with this. Otherwise, we don't know what it is. And then we have to actually handle that. So if I put this back to, like, I don't know, a caret. So now it's like, hey, unrecognized symbol, I don't even know what that is. But if this is our at sign, we actually go past that part of the code. It actually knows what this thing is. So where was I printing that out at? I'm printing out this. Okay. So now this should be a concatenation at this point. So we need to, I think, just throw this whole thing. I wonder if we can also leverage a flag for this. It's a decal info property. Do the only things that this would be on, are they decals? I think so. Which means I think we can leverage this. Let's add a new property here. And let's use this one and say concatenated identifier. I keep finding ways to make these names longer, which is fine. Here we can say the var decal node info, no, what are these property flags? These are on the these aren't on all of them. They should now be on anything that has a name, basically. Yeah. Anything that has a name needs to have these flags on it now. So we can say the var decal node info, this is a decal variable, flags, we're going to add this new flag. That this thing is a concatenated identifier, and we're going to go ahead and just append this to its name. right? So we already added to its name here. We're just going to append this next thing onto it. Plus equals text. And does this skip it? It does not. So then we skip it. Oh wait, does this not keep going though? We should keep doing this. As long as we keep seeing identifiers. Then we advance and say next is peek the next token. $157. Okay, now we don't handle this equals, which is a little weird. Unexpected token. Interesting. Unexpected unhandled token. So, we are... Okay, why are we not expecting an equals sign? That means I screwed something up here. So we grab the identifier. We skip to the next thing. Oh, okay. This should not be in here. This is not where this goes. This goes here. Okay, we're back to not understanding this part. So we grab the identifier that we know is there and we expect to be there. And then we look at the next thing and we keep going as long as we still see identifiers. And then we can do stuff like the array parameters and like all that other stuff. So, because I mean, we were never getting here, basically. We weren't getting here to eat the equals. So, okay. So now, we don't understand what variable is, which I assume is this one here. So if I comment this out, right? Great. So if I go look at the final output here, and we look at, or let's look at primary chunk actually. Stringify, or no, we want the final output. Variable underscore. So here we go. We're actually inserting this @ symbol, which means it is in the tree and getting to the last step of the process, which is codegen. It actually is getting there and getting into the tree, which is great. Because now the snippet parsing code wants to know about this. But does that happen up here too, is my question. So if I do this, like args or something, does that happen there too? Yes, it does. So this should not work. This should be a parsing error if we see that outside of a snippet. So let's do that as well. If not in snippet, is that what we called it? If not in snippet, var decal node, and this is a parse error. And we'll just say that IDENTIFIER concatenation can only happen, is only supported in snippets. Boom. It's only supported in snippets on 135.26. 135, right? So if we remove this, but we still do this down there, that should not trigger. It is triggering. Why? var decal node? Is this not getting created in its parent? It's not. Okay, this doesn't actually have a parent right now, which means So at this point we don't know we're in a snippet. That's a problem. Whenever we parse a variable decal, do we always come from a parent node? Yeah, yes, we do. So we could pass the parent in. There's really no other way that we can tell. That's so here, that's fine. We can pass the parent in. Here, where are we? We are in parse function variable or decal. So do we have a parent at this point? Not really. Let's see. This is either a regular function or a variable decal. If it's a variable decal, yeah, we have no context here. Well, we get the node. What do we do with it? We return it. Damn it. Here's where the parent would have to come from, all the way up here. So that's no good. Man, we need to know the parent here. We need to know where this thing is coming from. I guess we can let it go through and then catch it on the post pass, which I guess we'll have to do. Don't love that, but let's see if we can add that easily. Post pass. Find erroneous. Yeah, I really don't like that. That is such a waste of resources. The alternative is I have to figure out how to get the parent in here. in here. I guess one kind of gross thing I can do is in the parser, I could say snippet depth. You know what I'm saying? And then whenever we parse a snippet, I'm gonna say ++ snippet depth. Parser snippet depth. And then when we get out of parsing a snippet, no, that's gross too. I don't like that either, because we do that in a lot of different places. And that's another thing I would have to remember to do. Okay, don't love that. Well, there is a hacky way to do this. We could say parsing snippet, and here we will say parser parsing snippet is true. And then if we ever read a token and our root is global, right? If we're in global scope and we're parsing a snippet, we shouldn't be anymore. Right? This is gross, but I think it'll work. So then in snippet, this can just be if not parser parsing snippet. Okay, so that works here, but if I do what I did before and grab this, stick it here, right? So that works. It's gross though, I will admit. I will put it to do here. This is a gross and dumb and hacky way to handle detecting this. There must be a better way. But it's not rabbit hole on that. We're getting stuff working here, so let's keep going. So we can get rid of this, because this is not happening anymore. Okay, so now, in the codegen, update snippets, so update function call if snippet, that's fine. Update snippet calls. Connect declaref, snippet param. So what do we actually, where do we do this? Where do we do this? Replace snippet calls is where we do this. And actually, we already have a function called try to replace cast in snippet. Let's have another one that is try replace concats in snippet. First thing, determine if there is anything to concatenate. Right? So for each child node of the snippet, If it's not an identifier. Oh. No, if it's not a decal. If it's something that doesn't have a name. Do I have like an is decal var type? I do. Child. So if not a decal var type, then if num characters, what did I call that? Count for character. Count for character in the child's name Oh, wait, decal var type. That's not what I think it is. No, these are variables. Specifically. What I need here is actually more complicated. I need to check for all the different types it could be. For now, we'll just do this. To do this has to work for any decal type, or really any type with a concatenable name. Relying on the above assumption for this. So, let's just assert that, or let's say if count for character in the child's name actually, let's just do this. Let's just print that out, right? Need to replace int to string cats, I guess. Let's just see what that does. Try replace, update snippet for each child. If it's a cast, wait. Oh, okay, hold on. This is not doing what I thought it was doing. Try to replace concat in snippet. This I need. I don't need any of this. I just need the node, I guess. In node. So, for each child of the, so no, this is not how this works. This is actually just the node. And we only do that if okay, this is not where this goes. let's take this. Oops. Let's take this. Okay. And this is going to go down here. So replace snippet calls. So for each call, right? So here is where we create a copy, inserted. Okay. I feel like we should update this. So we're going to say so this is weird. I don't know why I'm doing it this way. Well, I guess I do, because we have parameters and stuff, but we create a whole copy, update the decal refs. Although I don't see where we're putting this back in the tree. Oh. Right. Okay. Yes. So this part right. This part I can pull out here for each child node of copy, or no, of snippet. God, I don't know. This is like the let me take another look at this, because all we're doing the same thing in both these cases. All we have to do is prepare what this is beforehand. So one's a copy, one is the source directly. So new snippet source, right? So new snippet source will be up here. It'll equal 0. Here, the new snippet source will be this. Right? And here, new snippet source will be this. Okay. Insert this snippet code into the tree. Remove the call. Okay. So, this should still work. New snippet source. Right. This is actually all the way out here. Although, wait a minute, hold on. No, I screwed something up. For each node of type in tree, so do keep going. I have an extra thing in here. Is that why? For each snippet call, keep going is true. Yes, this is... That was one too many. There. Okay. Great, we're back to normal. So, now we can say here, before we insert this into the tree, try to replace... this is only relevant if we have parameters, so that's up here. Try to replace, try to concatenate any names. Let's just call it, right? Try I removed what we were doing because it was not the right place. So let's say try concat nodes in snippet. It's going to take the snippet source and it's going to take the snippet copy. Although, wait a minute. Try concat nodes. Try to concat nodes in snippet. What does this actually take? We want to take the copy updates. What is that doing? So that actually updates them with the ones from the call source, which means I wonder if we can get away with just passing the copy. Let's just see if this works. If not, is declar type child continue. If let's do the same thing we were doing before. At count is count for characters, child info, decal variable name. has things to concatenate. Okay. Let's do that only if at count. Nothing. Not a great sign. So that's in here. Let's print out the name just because. Format expression, boom, 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 boom. Okay, I don't see this at all. Like, at all. I don't even see us trying to grab that. Which is weird. Is it because it's not a declvar type? Although, hold on. What would it be then? Of course it is. Okay, well, let's look at the tree. We can look at the tree because we're actually compiling. So here's the snippet. The argument. So here's the decl variable. Clearly it's there. Child node is not recursive. That's why. For each node of type in tree. Yeah, this is not great. Of type in tree. For each node of types. So I guess I could do this. It's gross. It's getting gross, more and more so. But we're gonna look for one, two, three, four, five, six things. Just gonna be these. Okay, and then for each node of types in tree, in the copy, types This is, don't have to do this. Handle more types. This is node. This is node. This is node. Okay, we don't actually, I don't think we need this now. I think we will find it this time. Yeah. Variable underscore at argument has one thing to concatenate. So that's great. The next step of this process then will be to parse this. Like now that we've grabbed it, we can parse this and try to connect it to so at this point, do we know what was there as a decal ref? I don't know if we do actually, because we did this first. Right, so we may have to combine these two things because this is the thing that knows how to connect argument here to the thing we passed in. That's what knows how to do that, is this. And by the time we call this, that information is gone. But this wants both this, but it also wants to know how this connects to this. So this function may have to get more robust to do this also. So let's do this, because it's getting late and it's Thursday, so let's say these two things may have to happen together in one function. Try to concatenate node and snippet wants both the call site info as well as the corresponding decal ref in the snippet. Update snippet copy decal refs is what makes that connection. However, when it's finished, that information is destroyed. Okay. So that's okay. I feel better suddenly about this concatenation stuff. This doesn't seem like as big of a problem as it was going to be. I do say here that we don't want to restrict it to just identifier names, which we are. And we're also limiting it to snippets, which I think makes sense anyway, because the only reason you would be concatenating something like this is if this is going to be replaced by something here, and that kind of textual replacement only happens in snippets, so that part's fine. But like, it'd be cool if you could concatenate in here too, and there's really nothing stopping me other than I guess if we're still limiting it to just snippets, there might not be anything stopping me from that. It would just be more work, but so actually I'm not going to do away with that concept just yet. restricting concatenation to just identifier names is dumb and lazy. However, to support more than that, let's not be so negative. Let's say is taking too many shortcuts. We should be able to extend this to things like types, function calls, etc. relatively painlessly, at least compared to my previous attempts at concat. Since we're now baking it into the name wherever it and letting the snippet metaprogram or snippet codegen handle the parsing and replacing, I think this is more feasible. Okay. Etc. Okay. I'm good with leaving it there for now. I really like slouching after, without even thinking about it. I should be here, and I'm like down here. But I'm okay with leaving it there for now. Things are broken, but currently broken. Still working on concat. Left in a broken state while we continue working on concat. There is a plan now. Okay. Didn't make a ton of progress overall, but like conceptually having a plan for snippets is really good. Or for concatenation is really good. I'm still a little bummed about the syntax because, well, once I have syntax highlighting, this will be less of a problem. But right now it's really hard to tell that this is, like ideally this, like the @ sign might be able to be white just like this. And then the thing that you're concatenating with, yeah, I don't know. We'll have to think about it, but it seems maybe okay. So anyway, thanks for watching if you watched this stream, and I will probably do more this weekend. So see everybody later.